We're continuing to bring you live coverage of the upcoming outbound powered flyby of Orion, now scheduled for 53 minutes and 30 seconds from now. Orion is already in the moon's sphere of influence, and yesterday the team completed a successful outbound trajectory correction burn. This burn helps set us up for the OPF burn, again coming up in about 53 minutes from now. At the time of the OPF burn, Orion will be 328 statute miles above the moon. And then just a short time from then, Orion will complete its closest approach to the moon at 81 miles above the lunar surface. Now, during this time, we will not have signal with Orion because it will be traveling behind the backside of the moon. However, we expect to regain communications once Orion swings back around to the other side and is back on the Deep Space Network. The outbound powered flyby will send Orion close enough to the lunar surface to leverage the moon's gravitational force and swing the spacecraft once around the moon toward entry into what we call a distant retrograde orbit. Following this, Orion will remain in the distant retrograde orbit for one long elliptical orbit around the moon, lasting about 6 days. Now, this orbit is called distant due to the high altitude from the moon. It's about 40,000 miles past the moon in its orbit, which is actually 30,000 miles farther than the previous record set during Apollo 13. And this will be the farthest in space any spacecraft built for humans will have ever flown. This orbit is also called retrograde because Orion will be traveling around the moon opposite the direction the moon travels around the Earth. This DRO provides a highly stable orbit where little fuel is required to stay for an extended trip in deep space in order to put Orion's systems through its paces and to the tests in an environment far from Earth ahead of crewed flights. Here in Mission Control Houston, things remain relatively calm now 5 days, 5 hours since Orion's liftoff aboard the Space Launch System from the Kennedy Space Center in Florida. The next major milestone that we're tracking ahead of today's burn will be a go-no-go poll where Flight Director Rick LeBrode will poll the team here in Mission Control on key systems required for the upcoming burn. On your screen, you're continuing to get a live view of the moon taken from one of the Solar Array Wing, or SAW, cameras on board the Orion spacecraft. Orion is traveling at 1,248 miles per hour and is only 2,600 miles away from the moon at this time. Again, upon closest approach, Orion will be about 80 miles off of the surface of the moon. Now, we will be in that anticipated and expected loss of signal during that closest approach. However, we do expect to regain signal with Orion just about 2 minutes after the closest approach, where we will regain communications with the vehicle. If you're just joining us, we're bringing you live coverage of today's upcoming outbound powered flyby burn, which will slingshot us around the backside of the moon. You are continuing to get views of the moon in real time here on your screen from a Solar Array Wing camera on board Orion. Today's burn will take place with the Orbital Maneuvering System, or OMS engine. This engine has been used several times throughout Orion's 5-day journey to the moon. This is that large engine located on the bottom of the service module. And the engine can provide 6,000 pounds of thrust. Today's burn will last 2 minutes and 30 seconds, but the burn can be used for burns lasting up to 16 minutes in length. The OMS engine onboard Orion is a repurposed Space Shuttle Orbital Maneuvering System engine that has flown in space before. It flew on 19 Space Shuttle flights, beginning with STS-41G in October of 1984 and ending with STS-112 in October of 2002. Now, the OMS engine is not the only engine on board the Orion spacecraft. There are also 8 auxiliary engines. These are located on the bottom of the service module as well, but in 4 sets of 2. These are used to provide trajectory corrections and as a backup to the main engine, and each engine provides about 100 pounds of thrust. In total, there are 33 engines aboard Orion, and here on your screen you are getting a quick glimpse of planet Earth. We do expect to regain those videos and imagery here shortly, but for now you're looking at a telemetry-driven animation of Orion and its location. As you can see here on your screen, speed continuing to pick up, now at 1,369 miles per hour. Over 232,000 miles from home, but only 2,000 miles away from the moon. Again, at closest approach will be just over 80 miles above the lunar surface, continuing to close in on the backside of the moon. At this time, we're 15 minutes away from the planned go, no-go poll, where Flight Director Rick LeBrode will poll the team here in Mission Control ahead of today's upcoming outbound powered flyby burn. And you're looking at a live view inside Mission Control Houston. We're in the White Flight Control Room today. There in the center of your screen, who just sat down, is Flight Director Rick LeBrode, who is leading the team here in Mission Control this morning. Sitting next to him is another Flight Director, Zeb Scoville. We'll have the opportunity to speak with Zeb here in just a few minutes about the upcoming burn. Orion is now 2,000 miles away from the moon, continuing to close in on its destination for this particular burn, the backside of the moon. The outbound powered flyby is the goal of today's operation. This outbound powered flyby will send Orion close enough to the lunar surface to leverage the moon's gravitational force and swing the spacecraft once around the moon toward entry into distant retrograde orbit. Following this, Orion will remain in the distant retrograde orbit for one long elliptical orbit around the moon, which will last about 6 days. Following this, Orion will perform a similar maneuver called the return powered flyby, which will put it on the trajectory to return back to Earth ahead of a splashdown in the Pacific Ocean on December 11th. Now, the first time a NASA vehicle flew behind the backside of the moon with crew on board was first done during Apollo 8. And here you are looking at a live view of the Orion spacecraft from the solar array wing with the moon in the distance of the screen, the Earth in the distant frame of the screen, and the moon up close. Again, we are now less than 2,000 miles away from the moon, but over 200,000 miles away from planet Earth. Orion started its journey 5 days ago from the Kennedy Space Center in Florida, where it launched aboard the Space Launch System. Orion has been traveling to the moon ever since, performing checkouts of its systems, as this is an uncrewed test flight. It's critical that NASA tests out the hardware and systems aboard Orion ahead of flying a crew on board Artemis 2. Good morning and welcome to the Johnson Space Center in Houston, Texas. I'm NASA's Sandra Jones and we're bringing you live coverage from Mission Control Houston of the upcoming outbound powered flyby in which Orion will fly behind the moon and perform a burn utilizing the Orbital Maneuvering System engine, which was checked out on Tuesday following launch of Orion atop the Space Launch System. The engine has been performing well and has completed a series of additional expected trajectory correction burns, and all spacecraft systems are performing well now over 5 days into the flight of Artemis 1. Today we're in the White Flight Control Room where Flight Director Rick LeBrode is leading the team on console for today's flyby and burn. Just moments ago, Flight Director Rick LeBrode polled the team here in Mission Control, and we are go for the OPF burn. We do expect to lose signal of Orion as it travels behind the backside of the moon, as the moon will be blocking the direct sight to the Deep Space Network. We're tracking that loss of signal to begin just about 10 minutes from now at 6:25 a.m. Central and will last just over 34 minutes. While in the loss of signal, the outbound powered flyby will take place with the Orbital Maneuvering System engine at 6:44 a.m. Central. The outbound powered flyby will send Orion close enough to the lunar surface to leverage the moon's gravitational force and swing the spacecraft once around the moon toward entry into distant retrograde orbit. Following this, Orion will remain in the distant retrograde orbit for one long elliptical orbit around the moon, lasting about 6 days. At this time, Orion is only 1,600 miles away from the moon. And you see this view on your screen as Orion continues to approach the backside of the moon, now traveling at over 1,776 miles per hour. And on the lower middle of your screen, you do see that's us, that's home. 232,000 miles away from Earth. Orion launched from the Kennedy Space Center in Florida 5 days ago, and we are now 25 minutes away from the outbound powered flyby maneuver. Today's burn will occur with the Orbital Maneuvering System, or OMS engine, which has been used several times already in Orion's flight. The OMS engine is located on the bottom of the service module and is the largest engine aboard Orion. It can provide 6,000 pounds of thrust and is equipped to help steer the spacecraft and can be used in some abort cases if necessary to safely return Orion to Earth. Now, today's burn will last for 2 minutes and 30 seconds, but the OMS engine can fire for up to 16 minutes. The OMS engine is a repurposed Space Shuttle Orbital Maneuvering System engine that has flown in space several times before, 19 times in fact, beginning on Space Shuttle Flight STS-41G in October of 1984 and ending with STS-112 in October 2002. Now, just about 5 minutes from now, we do expect to lose signal from Orion as it travels behind the moon. That loss of signal will last for 34 minutes. However, once Orion emerges from the backside of the moon and regains communications on the Deep Space Network, we do expect to regain communications with the vehicle. The burn will occur at 6:44 a.m. Central while we are in that loss of signal. And we'll also have the closest approach at that time period when we are in the loss of signal as well. That closest approach at 6:57 a.m. Central, when Orion will be just 81 miles above the lunar surface. Again, if you're just joining us, you are looking at a view from the Solar Array Wing or SAW camera on board the Orion spacecraft, which is 5 days into its mission, just 1,400 miles away from the moon. We'll continue to see the moon grow larger in the frame here in the next couple of minutes before we do lose signal from Orion as it flies behind the moon. Now you are seeing the Earth, you are seeing home, you are seeing yourself in that image right there, as Orion is 232,000 miles away from planet Earth. Now less than 4 minutes away from our expected loss of signal as Orion travels behind the moon. While behind the moon, Orion will perform the outbound powered flyby, which the team here in Mission Control is ready for. Flight Director Rick LeBrode pulled the team. Everyone is pulling go. Everything still on track for the outbound powered flyby burn, now 20 minutes away. This outbound powered flyby will send Orion close enough to the lunar surface to leverage the moon's gravitational force and swing the spacecraft once around the moon toward entry into distant retrograde orbit. Following this, Orion will remain in the distant retrograde orbit for one long elliptical around the moon, which will last about 6 days. Now, this is different than what was done during the Apollo program when the spacecraft orbited much closer to the moon. Now, this orbit is called distant due to the high altitude from the moon. It's about 40,000 miles past the moon in its orbit. This is actually 30,000 miles farther than the previous record set during Apollo 13 and will be the farthest in space any spacecraft built for humans will have ever flown. This orbit is called retrograde because Orion will travel around the moon opposite the direction the moon travels around Earth. Distant retrograde orbit provides a highly stable orbit where little fuel is required to stay for an extended trip in deep space and allows the opportunity to put Orion's systems to the test in an environment far from Earth. We are now less than 2 minutes away from our anticipated loss of signal as Orion travels behind the moon. As we continue to get live views here for the next minute or so, we will potentially see the Earth start to go just behind the moon as Orion travels behind the moon. We will not have Earth views, of course, because the moon will be blocking the Orion spacecraft. However, we do anticipate an acquisition of signal at 6:59 a.m. Central. It's about a 34-minute loss of signal, at which point we hope to regain communications with the spacecraft.